Hey Geometry, this is going to be our final exam review or semester one exam review, in other words. Um, but we've should have gone most of this that I'm going to go over with you right now, but you asked for a review, so I'm giving it to you. Let's get started. So on number one, like I said, I'm going to ask you to tell whether the polygon is concave or convex, then classify the polygon by the number of sides it has. And this over here is what you're going to need to memorize. According to the number of sides, you should know that 3 sides triangle, 4 sides a quadrilateral, 5 pentagon, and so on. So for this one right here, you can see that it is concave because of this right here, this side. And that if you count up all the sides, you would see that there's 6 sides. Therefore, it is a hexagon. For this one right here, there's no sides that cave in, so it's called a convex polygon. And then it's 5-sided, so you would label it pentagon. So you're going to have it just like this on your test. Where I say type, you put concave or convex. Classification, name the type of polygon that it is. All right. Number 2, you're going to use an image similar to this one right here to figure out certain types of questions that I have for you, like I do right here. Oops, don't underline. Okay. So on part A, it asks us to name 2 points that are collinear. There are many answers to this one. Just find 2 points. Those points are going to be collinear. So, for example, we can actually use the points A and B. Okay? And you're done. Just name 2 points. You don't have to name the line or anything like that. Okay, then part B, it says name 3 points that are planar. Well, to create a plane, you at least need 3 points. So there's a few examples of that too. So in this plane right here, we have 3 points, E, D, F. There's your 3 points that you can use. Or in this plane down here, you can use that A, B, and C are coplanar. So either answer will work. So E, D, F. Sorry, I'm not used to writing with this pen. And A, B, C. So all 3 are points. So either one of those. And name the line that intersects both planes. So you can see that there is a line intersecting these 2 planes. Name that line. The only name that it does have are the points that are on it. So DB or BD. Either way you want to state it, just make sure you state it properly. So BD, that is partial credit right there if you leave it just like that. But what I'm going to need is that this is a line. So put the notation that this is line BD. Okay, for part D, it asks, are points F, D, B, and C coplanar? So F, D, B, and C. The answer would be no. F, D, B, C. You could possibly create a plane with these 4 points, but since it is not drawn in there for you, we don't know that if say for instance that C is part of the plane that F, D, and B are actually in. So the answer for this one would be no. Um, you can I could have said are F, D, and B coplanar. Then you would have said yes, because 3 points, any 3 points, create a plane. Now, part E are points E and C collinear. Well, this is going to be yes. Any 2 points that I name, no matter if there is a line drawn through them, they are going to be collinear because you can draw a line through any 2 points, or there exists a line through any 2 points. So here, kind of a trick question there is yes. Now, just like I showed you in class, one like this where you use the segment addition postulate says find the lengths or find the length xy in the figure shown. So we are turn this off. We are given this right here that xy plus yz is equal to xz. That is the segment addition postulate. Plug in what you know. So you don't know xy, that's what we're trying to figure out. And we know that yz is 11, and then xz is 17. All right, you have an equation. Solve it for xy. And so xy is 6. Also be able to do this with an angle, the angle addition postulate. Kind of the same thing. I'll draw a quick example here. Let me get my pen tool out. Okay, so say I have an angle measurement here that's split. Let's call that vertex B, that point A, this point C, and that one point D. And then you are given measurement of angle ABC is equal to 20 degrees. And then you are given the measurement of angle ABD is equal to, let's say, 60 degrees. And what is the measurement? We're going to try to figure out the measurement of angle CBD. What is that? Well, it's the angle addition postulate is what is being used here. We should know, I'm going to come up here. Let's see. You should know that the measurement of angle ABC plus, let's undo that. The measurement, oops. Measurement of ABC plus the measurement of angle CBD is equal to the measurement of angle ABD. All right, so that is the segment addition postulate. It just states that 2 angles on the inside of a bigger angle are, when you add them up, they're equal to that bigger angle. So what we're going to do here is plug away. We know that ABC is equal to 20. And then we don't know this one. That's what we're asked to find. And then the measurement of angle ABD, that's 60. So you got your equation here. Solve for angle CBD, which is 40 degrees. Okay, so that's how you use the angle addition postulate. Very similar to the segment addition postulate. Now, on number 4 here, it says find the exact distance between the points given and the coordinates of the midpoint. Okay, so I state exact. Okay, if I asked you to approximate, then you're going to do an approximation, plug away into your calculator. But I want exact, and I will state that on your test. But you will be given this right here, the distance formula, and you will also be given the midpoint formula, this right here. What you have to do is be able to use these two things. Given that these are your points, A and B, on your coordinate plane somewhere, and you plug them into your formula the proper way, and then you reduce it the proper way. So follow these steps right here that I've given you and look those over. If you have any questions, please email me about them. Same thing goes with the midpoint formula. Plug them away into your formula. Reduce each of your x and y values down as much as possible, and then you will get your solution. Okay, number 5 here, things that deal with supplementary and complementary is what this one is about. So I will give you something just like this. Given measurement of angle 1 is 52 degrees, find the measurement of angle 2 if 1 and 2 are complementary. So that's the first one. And this is how you can do that. So complementary angles, they add up. So 1 and 2, they add up to 90 degrees. Just like the angle or segment addition postulate, plug in what you know. You know that angle 1 is 52 degrees, solve for angle 2. Same thing goes with supplementary, except we have these two angles add up to 180 degrees. Okay, so plug away 52 into your measurement of angle 1 and solve again. And you get the measure of angle 2 is 128. Okay, this is the pattern recognition one. This is just a simple example of what I'm going to be showing you on your test. You may have a number one or you may have a shape one where you have to identify the pattern that's going on in the shape or the figure that I give you. So what this is this is what I'm going to give you right here, 1, 9, 25, 49. And you have to figure out that, well, this is the pattern. 1 here, same thing as 1 squared. 9, same thing as 3 squared. 25 is 5 squared. 49 is 7 squared. So the next one in the pattern is 9 squared. Notice we're going by odd numbers. We're squaring all of our odd numbers here. 1, 3, 5, 7, 9. And then your answer would be 81. Okay, be able to, like I said in class, match these statements with their property. So I'm going to give you these statements that are out here. It may not necessarily be the transitive property of congruence. It can be the transitive and symmetric and reflexive property of equality instead of congruence. I may give you that. So look over those two, but they are very similar to one another. The only difference is that instead of a congruent symbol in those properties of equality, you have an equal sign. Okay, and also you don't have bars over anything. You don't have the bar over A and B or C and D and E and F because you're stating equal distances between points. So that's a little different. But know these properties and be able to match them to the correct property and you should be good. For this one, again, another matching one. I give you a statement just like this, piano players are musicians, and be able to match the statement to its correct form. If then form is also called the conditional statement. I'm going to write that in, conditional statement. So be able to recognize all of these different forms. Study up on that. Remember, if then form is just this statement written into an if-then form. So like this one right here. If you are a piano player, then you are a musician. That's just changing this right here, this statement, into an if-then statement. Now, for B, the inverse, remember you put not on both of your hypothesis and conclusion. That's what changes. So that is the statement right here. If you're not a piano player, then you are not a musician. And the converse, let's go to that one first. The converse of a statement is you switch the hypothesis and conclusion. So from A here, switch are a piano player and are a musician, and you've got it. If you are not, oh, hold up. This one right here. If you are not a musician, then you are not a piano player. Sorry, I said nots in there. Did not mean to. If you are a musician, then you are a piano player. That's it. Contrapositive. This is one I was trying to read, but not the correct one. But here we go. Contrapositive is a combination of the inverse and the converse. And what you are doing is you are switching the hypothesis and conclusion and putting nots on both of them. So you're negating them is another formal way of saying putting nots on both of them. But anyway, so contrapositive is this statement right here. If you are not a musician, then you are not a piano player. Often if this statement, well, always, if your if-then statement is a true statement, then a way to tell that your contrapositive is done correctly, it is also a true statement. So just kind of a quick tidbit there, hint that a way to figure out if you have a conditional statement and the correct contrapositive of that conditional statement. All right, number 9, you are going to be given something just like this right here, an equation. And what I want you to be able to do is take this equation and solve it in some way. You don't have to do it exactly. There's not one way of doing an equation many times, especially if there's many steps. But the way I do this is, okay, this is going to be given to you. The first step I did was I distributed that 3. So if you do use the distributive property, state it. It's the distributive property. The next step, what I did was I combined like terms. I combined the 3 and the 4. The negative 3 minus 4 is negative 7. So that's what I get right here. And I stated combined like terms. Or at this point, you can also say simplify. Means the same thing pretty much. Okay, from step 3 to step 4, what I had done is I added 7 to both sides of the equation. So when I do that, I get positive 3 on this side. So that's the addition property. And then from step 4 to step 5, I subtracted this 2x from both sides, which gives me x equals 3, and you use the subtraction property to get there. So that is number 9. Here, you were to fill in the blanks by referring to this image right here. These that are underlined right here, awkwardly, but they're underlined, are what you're going to need to fill in. And I went ahead and did that. So you're going to be given a statement like this. Angle 1 and blank are corresponding angles. So you would say angle 1 and angle 5. So what you're going to need to do to know this part of the test is go back and study corresponding consecutive alternate interior, alternate exterior angles, and also vertical angles in linear pair. Remember those other two. Here, angle 1 and angle 4 are vertical angles. A quick and easy way to figure out you have vertical angles is that notice this right here. 4 and 2 are they kind of, the angles that they create, they look like V's. One's a V this way and one's a kind of an upside or sideways V to the other way for vertical angles there. Now part C here, angle 3 and blank are consecutive interior angles. Well, this right here means they are on the same side. Consecutive means same side. And interior, meaning interior of the parallel lines. So inside these. What happens on the outside of the parallel lines are exterior. Inside is interior. So the only angle that is a consecutive interior angle to angle 3 is this one right here, angle 6. Okay, part D, angle 4 and angle 6 are alternate interior angles. And this is true. Alternate interior means they are on the opposite side of the transversal. So 4 and on the opposite side, your only choices are 3 and 6 here because they are both on the interior, but the only one that is alternate interior is the one that is down here, alternate interior. So 4 and 6. Alternate exterior, kind of the same way, except their two angles are on the exterior of these two parallel lines that we have. So angle 8 and opposite side, angle 2 right here, are on the exterior and they're on the opposite side. So alternate exterior for that one. Okay, to go along with the same figure, I ask you to use the same image. And since these two right here are parallel to each other, we have properties about parallel lines where several angles are congruent to each other or they are supplementary to each other. And what I've given you is that the measurement of angle 3 is equal to 122 degrees. So if measurement of angle 3 is 122 degrees, then you should know that angle 3, 1, 5, and 7 are also going to be 122 degrees. As a way to figure out 2, 4, 6, and 8 are just like this. Angle 1 is supplementary, angle 3, what we start out with. Angle 3 is supplementary to angle 2. So take your measurement that you're given, 122, subtract it from 180, and you've got your other angle measurement for the rest of the angles that you have left. So angle 2, 4, 6, and 8 are all going to be 52 degrees, as it's stated here. Okay, still kind of going along with alternate exterior, alternate interior, and other sorts of angles that we have studied before. You're going to be given a problem similar to this. You're asked to find the value of x. So since these are parallel lines and these angles right here that are labeled 137 degrees and then the 4x plus 5 degrees, these angles are alternate exterior angles. These two angles are going to be congruent to each other. So how you solve for x is you set them equal to each other. So 137 degrees equals 4x plus 5. Solve for x, which is right here what I've done in the steps. Okay, you're not going to have one this easy. I'm sorry about the angle, side angle, and side angle, side, and the rest of these. But you are going to be given something similar to this. Like I said, not as easy of figures here to use to match up to all of these theorems, but something similar. But here we go. Match the theorem with the correct pair of congruent triangles. So right here, these two triangles, it's labeling that all three corresponding sides are congruent to each other. So what you're going to be putting here is side, 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 or choose this right here, D. Okay. Now on this next one right here, this right here, go in order, like counterclockwise or clockwise. Either way, you're going to end up with the same thing. This one starts out with side, then goes to the angle, and then side. So that's what theorem it is. Side, angle, side, which is, where is it? B. Now let's look at this one right here. We have two triangles. Again, go around counterclockwise or clockwise. We start out with an angle, two angles, another angle, and then a side. So angle, angle, side, which is option E. Okay. This one right here, let's look at this. We have, again, going in a counterclockwise motion, we have two angles, then a side, then another angle. Okay, so angle, side, angle is what that is going to be. So choose A for that one. Now this last one here, it is the one that has a right angle in it. And just to make sure you're paying attention for this one, I am going to tell you that there's going to be other triangles in here on your test that have right angles in it. So this isn't the case for all the time, but for the hypotenuse leg, it is going to have a right angle in it. And what you have to show congruent in the two triangles is the hypotenuse, which is the longest side in the triangle. If you can figure that one out, please do. Longest side in the triangle is the hypotenuse, or another way of looking at it is this right here. The side opposite of the right angle. So here's the right angle. Go to the side opposite, which is this one right here. Side opposite of the right angle, again, that one right there. All right, so just note that hypotenuse leg must be two right triangles that are being shown or possibly shown congruent. Anyway, so hypotenuse and then just one of the legs. Both of the other sides of the triangle are called the legs. Just make sure two other legs are being shown congruent in each of the triangles. So here we go. This one right here is C. All right. 14 here. This is something similar like what you will have on your test. There's just 4 fill in the blank spots here for you to do this proof. First part, you should know number 1. That I am just giving you points right there. So, first one, let me get this tool working properly here. All right. So for statement 1, you are going to write given, because that is the exact statement up here. Okay, and then on statement number 2, let's look at what we have first. Given angle K and angle N are congruent, so K and N are congruent. And then angle KML is congruent to NML, okay? So this one right here, sorry. All right, so those two angles are given to us, that they are congruent. And part two is name another congruent statement that we can name, that we know for a fact about these two triangles, KLM and NLM. All right. The only other thing that we know for each part of these two triangles that are congruent are the two sides that they have in common with each other, which is that right there, LM. So we can state that LM, segment LM, is congruent to LM. All right. That is the reflexive property. So state that. And then triangle KML is congruent to triangle NML. What that is true. And tell me which congruence theorem or postulate you know that. The reason why you know that is one of those. Angle, side angle, side, or something like that. One of those statements. And you should know you have a list of all of those from the previous one. One of these five are going to be your answer to number 3 here. So number 3 here, since we went from angle, angle, side on each of the, going around the counterclockwise top motion here, that's what you used is angle, angle, side. So again, let's see, write it down. Angle, angle, side. And you don't necessarily have to say congruence property or congruence theorem or postulate. Just write AAS. And you're done with that one. Okay, so ignore all these numbers that I have on here so far, and let's just go with this. I'm going to relabel these letters on this in this figure here too. It asks us, what is the value of x? Well, what I'm going to tell you is that this triangle right here, pay attention to what segments are congruent and stuff like that, and your angle measurements and things, to be able to tell what values you're going to figure out for your two triangles in this figure. Okay, so what is the value of x? Well, this right here, these two little segments that are being shown congruent, tells us that this triangle right here is a isosceles triangle, which means that our two angles, or two base angles, are going to be congruent. Therefore, x is equal to 75, like I have written right here. And then it says, what is the value of y? I went ahead and added in that we need this angle measurement right here, that is equal to 30 degrees, just because we haven't gotten into part of the book where we know the measurement of all the angles inside of a quadrilateral is equal to 100 or 360 degrees. But let's keep on going. So using that this is 30 degrees, this is 90 degrees, what is y? Well, with this triangle right here, use our triangle sum theorem, add up all of your angles, and set it equal to 180 to figure out what this measurement is equal to. So y plus 90 plus 30 is equal to 180. Y is equal to 60 degrees. Okay, the last thing I want you to do is classify the triangles. Okay, so I've relabeled the points along this quadrilateral where all the vertices are to help us classify these triangles that I've named. So it asks us to classify triangle ABC. Well, on these, I am actually going to ask you to classify it by side and angle. Okay, so for this one, we should know that if looking at triangle ABC, ABC is right here. We should know that because of these two congruent lines, that this is a isosceles triangle. So part of your label is an isosceles triangle, but also another part is that, well, since we know that these two angle measurements are 75 degrees, this right here is going to be an acute angle. Let me figure that out real quick. Let's see. Out of a 180 degrees, that last angle measurement right here is actually going to be 30 degrees. Okay, so with that being a 30-degree measurement and the rest of the angles, they're all acute. This is an acute isosceles triangle. So that's how I'm going to want you to label it, an acute isosceles triangle. And then for a triangle BCD, this one right here, BCD, this is definitely a right triangle, but we don't know of any side measurements. So what we're going to call this is well, all the side measurements are actually going to be different. You can use a ruler or something to measure that, but you don't need it. None of them are labeled as congruent sides on the triangle A or CD BCD. That's the triangle I'm talking about. So automatically, if there's no sides labeled, no sides being shown congruent on your triangles, then that's a scalene triangle. So this right here is a right scalene triangle. So right scalene for that one. And then I said acute isosceles for part C. Okay, last thing I'm going to be showing you on this slide, on this video, is things that we had just learned about translations and reflections and rotations and even dilations. Is this right here. You're going to have to perform the following transformation to a triangle that I give you, and it's going to be graphed. So you won't necessarily have these points right here that I label. You're going to have to find those on the graph. These are going to be the points of your vertices of your triangle. And then after you perform all of these transformations on your triangle, like I've done here, you're going to graph it. You're going to graph the final product on the graph given to you. So here's how we start out figuring out what our new points of for our vertices of each of our vertices here are going to be after doing all these transformations on it. What we need to do is start out with the first one, then go to the second one, and then go to the third one. Okay, so perform the translation on your first thing on each of your vertices. Okay, so that's this step right here. My vertices that I've given is A is 0, 2. The translation, subtract 2, add 2 to y, and you're good. You got your new one, your new point for that vertice. And then for part B, or for vertice B, do the same thing. Subtract 2 from x, add 2 to y, and you've got that point there. And then C, do the same thing. Okay, and then when I've asked you to do the reflection on the whatever axis or across y equals x or y equals negative x, this is just, you will be given this thing right here. I just put it in red because that is one thing you will be given on the test is your reflections and rotation rules. So on this reflection over the y-axis, we need to use this rule right here on what you just translated. So this right here, reflect that across the y-axis. So following this rule, we need to make this point -2, 4 into this version of it right here, negative whatever your x value is, and keep your y value the same. So if it's already negative, then change it to a positive. That's why I put the second image of A double prime is 2, 4. And then do the same thing with B. Use this one right here and do the negative A, B. So -0 just stays 0, and then 5. For C, -3 changes to 3, and then 0 stays the same. Now, same thing. After you reflected it, we're going to rotate it now. So from your A, B, and C image right here, we're going to rotate these points 90 degrees. So this is the rule for 90 degrees. Like I said, you'd be given that. And so the rotation is, for the 90 degrees, is switch A and B and put a negative on that A. So for this point right here, switch 4 and 2, place a negative on the 2, and you've got it, 4, -2. All right, same goes with this one. Switch 5 and 0, put a negative on the second part, but like I said, -0 is still 0. And then here, switch these two around, so you get 0, 3, then put a negative on the 3, and you're done. And then once you are done figuring out what the points are of your new image, I'm going to want you to plot just the third one alone, just the A triple prime and B and C. You don't have to graph any of these others, just the final result of all of the transformations after this. One last thing I expect you to know how to do is how to perform a dilation on a, again, on an image like this right here. You're going to be given a triangle or quadrilateral or something that's already graphed, and I'm going to ask you to perform a dilation on it. Now, dilations, it's a lot like this right here where it says rotation and then 90 degrees. What you will be given is something like this right here. You'll be given dilation. I think that's how you spell it. And it'll say scale factor of, let's say, 3. So what you do with that scale factor is this right here. Sorry, I'm going to copy and paste this real quick. This is what your rule is going to be for this one. Using that scale factor, you're going to just say 3 times x and 3 times y. And that right there is going to be your new image of the given points that you have. So given your scale factor, take that scale factor, multiply both x and y by that scale factor, and that's how you do the dilation. Okay, so that is it, and I'm going to let y'all all go. Study hard and be prepared for tomorrow's test. If you have watched this, you should be very well prepared. Goodbye, everybody. See you in class.